Controlling noise at the source is most effective measure. Selecting high efficiency and low noise equipment and avoiding the equipment from rooms that need to be quiet are ways to effectively isolate noise transmission. In addition, it is also possible to add an acoustic enclosure to the equipment and a muffler to the pipeline. Acoustic enclosures are used to isolate equipment noise. Functions include sound insulation, sound absorption, damping, vibration isolation, ventilation, noise reduction, etc. The structure includes a cell, a damping layer, a sound absorption material, and a protective layer. The cell can be made of steel, polywood, plasterboard, or aluminum. The damping layer adopts damping paint, asphalt plus fiber fabric or fiber material. The sound-absorbing material there is ultrafine glass wool or foam plastic. The protective layer adopts perforated plate, wear mask, or glass cloth. The minimum clearance between the acoustic enclosures and the machine is 5 cm, and a rub cushion between the cover and the foundation for vibration isolation. For equipment that needs to dissipate heat, a ventilation pipe with noise reduction function is required on the acoustic enclosures. Types of acoustic enclosures include fully enclosed, partly open, fixed, or movable. This diagram shows 3 types of acoustic enclosures. Among them, Picture A only uses acoustic enclosures without vibration isolation and internal sound absorption. Picture B adds a vibration isolator on the basis of Picture A, and Picture C adds sound-absorbing material on the basis of Picture B. The figure below shows the sound insulation effect of 3 kinds of acoustic enclosures. It can be seen from this that the sound pressure level has been greatly reduced compared with the original, especially the high-frequency part has a large reduction. The noise reduction effect is that the image C is larger than the image B is larger than the image A. It can be seen that the acoustic enclosure needs to be provided with vibration isolation and sound absorption in order to ensure a good sound insulation effect. The acoustic enclosure uses insertion loss IL to indicate its actual noise reduction effect, which indicates the difference in sound pressure level before and after adding a cover at a certain point in the space outside the cover. It can be seen from the formula that the insertion loss is related to the average sound absorption coefficient in the cover and the average transmission coefficient of the cover. When the average sound absorption coefficient is equal to the transmission coefficient, the insertion loss is equal to 0. Therefore, the sound absorption coefficient cannot be too small. Next, let's do an exercise. A device is to be equipped with acoustic enclosure. The sound pressure level at the original receiving point is 90 dB, which is to be reduced to 60 dB. The inner surface of the cover is to be made of absorbing material with an average sound absorption coefficient of 0.5. Find the sound insulation that the acoustic enclosure needs to meet. The insertion loss IL is equal to 90 minus 60, which is equal to 30 dB. Substitute it into the calculation formula of IL, and the sound insulation R that the sound insulation cover needs to achieve is 33 dB. The airflow noise is mainly caused by the turbulent flow of the gas flowing into the pipeline, or the high-speed jet at the pipeline outlet, and the pipeline vibration excited by the airflow. A muffler is a device that allows airflow to pass while reducing airflow noise. The basic requirements for a muffler are: the first, better silencing frequency characteristics. The second, the air resistance loss is small. The third, simple structure, convenient construction, long life, small size and low cost. These requirements affect each other and restrict each other, and it is difficult to satisfy all of them. It can be emphasized according to the actual situation. The design steps of the muffler are: the first, calculate the required muffling amount for each frequency band according to the frequency spectrum of the noise source and the noise control standard. The amount of noise reduction required for each frequency band is equal to the sound power level of sound source in this frequency band, minus the natural attenuation of sound source to the control point, minus the noise level followed by the control point, plus the noise level caused by unfavorable factors. The second, select the muffler form according to the required muffler amount for each frequency band. The third, calculate the required length of the muffler. The selection size of the muffler is determined according to the size of the connected pipe and does not need to be calculated. The types of muffler are divided into three types: resistive, resistant, and impedance compound, according to the required muffler spectral characteristics. Among them, the resistive muffler is arranged in the pipeline with resistive materials, such as porous sound-absorbing materials, to absorb sound energy, which is suitable for eliminating medium and high-frequency noise. Resistant mufflers use the principles of sound resonance, reflection, interference, etc. to achieve the purpose of muffling and are suitable for eliminating medium and low-frequency noise. Only the design calculation method of resistive muffler is introduced here. Picture A is a square stringed tube type, and Picture B is a round stringed tube type. Formula 1 is the calculation formula of the sound deadening capacity, and Formula 2 is the calculation formula of the upper limit failure frequency. The upper limit failure frequency refers to the frequency at which the silencing coefficient decreases significantly. Because the noise elimination coefficient is not only related to the sound absorption coefficient of the material, but also to the specific acoustic impedance, absorption frequency, channel cross-sectional area, and other factors of the material. When the sound absorption coefficient is large, the frequency is high and the channel section is large. The high-frequency sound wave propagates along the channel in the form of a narrow sound beam, with reduced sound deadening capacity supply. Next, let's do an exercise. The section size of the pipeline is 400 mm times 600 mm, and the inner wall is affixed with a porous sound-absorbing material with a thickness of 50 mm and a sound absorption coefficient of 0.5 at 250 Hz. The required sound attenuation at this frequency is 8 dB. Find the length of the muffler and the upper limit of the failure frequency. It can be seen from the figure that the section size of the muffler is the same as that of the pipeline, and its effective section size needs to deduct the thickness of the sound-absorbing material. The effective section parameter P is equal to RA plus RB, which is equal to 1.6 meter. The square sectional area S is equal to A times B, which equals 0.15 square meter. According to the sound absorption coefficient of 0.5, the sound elimination coefficient is 0.75. Substitute into Formula 1 to get the effective length of the muffler 1 meter. Substitute into Formula 2 to get the upper limit failure frequency of 1530 Hz. This example is only for the calculation of the size of the muffler. You can try to analyze the frequency spectrum of the noise source and calculate the amount of muffler in each frequency band. For other types of muffler calculation measures, you can refer to the relevant design manuals. In addition, please teach yourself about the application of sound insulation chamber, acoustic barrier, and masking effects in the indoor noise control, as well as urban noise control measures. At this point, the contact of building physical is all finished. Thank you.